Okay, good morning. Welcome to
SuperMath number 121.
SuperMath121. We're continuing our exploration of some basic proofs in geometry. And we're looking at, today, we walked through, when you have an obtuse triangle, that the long side, the side opposite the obtuse angle, squared is greater than AB squared plus BC squared. So it's sort of the greater than Pythagorean theorem.
Yeah.
And this is interesting. There's no information. This isn't like one of the math contest problems where they set you up with a bunch of information.
Yeah.
And say, find an answer. You just have a triangle here, and you have no information about it, and you're supposed to prove this identity. That's really interesting. This gets into what theoretical math is about. How do we learn things like this just from these basic properties of triangles? And what do you think we're going to use to prove this?
Well, probably, since there's squares, we're probably going to use the Pythagorean theorem.
The Pythagorean theorem is going to come into play, and that gives us our first hint of what we want. Because we think we're going to need the Pythagorean theorem. So if we're going to use the Pythagorean theorem, what do we need?
Right triangles.
Okay, and where is a nice right triangle in here?
Well,
my marker might be a little better. Well, a little better.
There's one right there.
Okay, so then why don't we call that D, I guess. That's what the book called it. Alright, so we make a new right triangle. And we're going to use the Pythagorean theorem. And what's nice about this right triangle? What does it tell us?
Well, it tells us that AC squared is AD squared plus DC squared.
Okay, it tells us that AC squared equals AD squared plus DB plus DC squared. So now we know what AC squared is. So that's nice, actually.
But we don't have AB squared or BC squared.
Right, we don't have anything relating to AB and BC. We just have AD and DC. But it still feels like we're walking down the right path. And by the way, sometimes you feel like you're walking down the right path and there ends up being a wall at the end of the path.
Yeah.
But we'll see. We'll see.
Well,
what else do we know here?
This altitude that we drew also creates another right triangle.
Okay.
That we can say AB squared is AD squared plus DB squared.
Ah, we get another right triangle right here. I'll call this right triangle 2. AB squared equals AD squared plus DB squared. Now that's nice. Why? What's nice about this equation?
Well, we have an AB.
We have an AB squared, and why is that nice?
Because that's what's in the final final proof.
We want that, okay?
Yeah.
So how are we going to use this equation?
Well, too bad. Well, actually, we could say. We can say this equation, AC squared is AD squared plus, DB plus BC squared.
Oh, interesting. Okay.
So, we have a DB in here and a DB in there.
All right, good.
So, we could move this to the other side and get an equation for DB squared.
Okay, interesting idea. Interesting idea.
Well, let's see where this goes.
Okay.
So, DB plus BC squared, well, it's DB squared plus 2DB times BC plus BC squared.
Okay. Let me just see if you're on camera there or not, because if you're not, I want to widen out our shot. All right, I guess you are. Oh, but I see we're at 5 minutes, so I'm just going to stop and restart, okay?
All right.